In this video, my goal is to get this Knight KG600B tube tester working properly. If you recall from the earlier video, I also have a second one of these with a damaged meter. I did take it apart, and my thought was that maybe I could find something obvious that was wrong with it and get it working properly, but the needle movement does seem to be damaged. As near as I can tell, the problem is the pivot points. They're just not, it's not rotating freely inside there. I can't find any obvious stray material that might have gotten caught up in there. But what I did manage to do is extricate the meter face. It turns out also that this meter is a 1 milliamp meter, and those are very common on eBay. There's probably over a dozen of them for $10 and less right now, so I don't think I'll have too much trouble finding a replacement. I think mainly it will be a matter of finding one that has the right dimensions so it mounts in these same holes. In the parts list, I just have it listed as a meter 1 milliamp movement, 4.5 inch. Not sure that's 4.5 inches across or diagonally. Now, as for this one, it seems to be working properly, but it's not calibrated. When I've tested some tubes, the needle just pegs all the way over to the right. So what I want to do first is pop this open and check all the components inside. There aren't many. Just one capacitor, a 0.1 microfarad rated for 400 volts, and a handful of resistors. So I want to check all those. Actually, the capacitor I'm just going to replace. I won't even bother testing it. And then I'll test these resistors. Once that's done, I will go through the calibration procedure. As for getting this open, well, let's see. It looks like there's a series of flat-headed screws around the perimeter. I'll help you get those out. Okay, I got all the screws out, so this should lift out. Alright. Now these were sold as kits. So, this was done by a hobbyist, I imagine. They may have also sold these as pre-wired, I'm not sure. But if you flip through this manual that came with it, you can see there's check marks where somebody had checked off the steps as they completed them. So I'm pretty sure that somebody did assemble this on their own. But it looks like they did a pretty nice job. So, let's see, here's our one capacitor. There's a calibration control. There's various resistors. And that is just about it. Got the multi-tapped power transformer here for different filament voltages, and then there's the line adjust rheostat. So, I'll start out by pulling out a replacement cap for this guy, and I'll start checking these resistors. I've replaced the capacitor, now I'm checking the resistors, and not surprisingly, a lot of them are out of spec. For example, this should be a 270 kilo ohm resistor, and it's measuring 316.6. These should be within a 10% tolerance, so 270K plus 10% would be 270 plus 27, or a shade under 300, so it's definitely out of tolerance. Next to it is a 100K. It's measuring 111, which is just outside the 10K range. And so on and so forth as I've been checking these. This should be 1.5K. It's 1.6. This should be 51. And it's 53.8. So, long story short, I'm going to replace all these, at least all the half watters. There was one larger one back here. There is one power resistor back here, and I hope I don't have to replace that, because I don't think I have a 2.5K 10 watt resistor on hand. So let's see. 2.49. I'm not surprised by that, because often these are wire wound resistors, and they really do not ever go out of tolerance. They might burn out, they might fail, they might get corroded, but generally the resistance doesn't change. Okay, I finished replacing all those old half-watt carbon composition resistors. I used half-watt metal film 1% precision resistors. They should hold up for a long time. Now, while I've got this exposed, I'm going to clean the switches with some deoxit and put a few drops of oil on this mechanism for the roll chart. Then I'll move on to the calibration procedure. The calibration procedure for this tester is fairly straightforward, but a little dangerous, so be careful while you're doing this. There's only one adjustment to make. It's this control right here. You need to do this while this is turned on and all this wiring is exposed. That's why I say it's a little dangerous. What you need to do is set the front panel controls for a type 6V6 tube. Turn this tube tester on. Hook up an AC voltmeter to pins 2 and 7 of the octal socket. Set the line adjust so that your voltmeter reads exactly 6.3 volts. And then you tweak this control so that the line set on the meter is, rather the needle on the line adjust is directly on it. It'll make more sense if I turn this around. So basically every tube tester, you've got a control called line adjust. What this does is it compensates for varying line voltages. In one location, somebody may have 110 volts AC at the outlet. Somebody else may have 120 volts. Somebody else may have 125. This control compensates for that. So while you're doing the line test, you need to get this needle dead center. What that really means is, say you're testing a tube that's supposed to run on 6.3 volts AC, it means that you're going to have exactly 6.3 volts AC on the filament pins, as long as you've got your line test set up right. What this line adjust actually is, it's a rheostat on the AC line. Let's see in the schematic here. So there is the line adjust. Sort of a crude form of a variac. Rather than having an actual adjustable primary, they've got a big wire wound resistor and they're shunting part of the primary winding with it. Alright, now unfortunately you can't make the adjustment while it's like this because you've got to get at that control. So I'm going to try to rig this up so it's on its side so I can access both sides of this simultaneously. I figure for the first part of this procedure I can do it with the set assembled as normal. So I've got my AC meter probes in pins 2 and pin 7 of the octal socket. That's one over from the keyway. So right on either side of the keyway is 1 and 8, so just go one more over in either direction. I've already flipped the levers and switches and such for a type 6V6. And I'm going to turn it on. Alright, it's a good sign. It turned on. We've got the backlight going on the setup chart here, and the meter has deflected. One thing you should check too is before you turn it on, make sure the needle pointer is dead on 0. There's an adjustment screw here if you need to tweak it a bit. Alright, I've got the filament off right now, so let's turn that off. So right now it's on 2, and I've got 1.9697. Well, they want us to go up to 6.3, so there we are. We get 6.43, so we can see we're off. Now they say to adjust this control so you get 6.3. Forget about where this needle's pointing. Just get this on 6.3. So dropping it down a bit. And back the other way. Alright, there, 6.3. Now, if you look at this needle, you can see it's well off of center. If this was calibrated properly, that should be right down the middle, right on that little tick mark there between the word line and test. So I needed to adjust that control underneath to get that to line up. So I'm going to see if I can carefully tip this tip the top of this tester up and get an insulated screwdriver in there and start tweaking it. Well, I tried making the adjustment, but this control only varies the meter for about 10% of its travel, then it stops having any effect whatsoever, which makes me suspect that this little trimmer control might be bad. So I gotta do a little more investigating on that. Upon further investigation, I discovered that the brake in this rheostat was very near one leg. Now the other leg isn't used, but it's fine from this leg all the way almost to the other side. So what I did is I soldered a wire onto the lug, which had been trimmed off very close to the base there, and I hooked up a meter, and I'm getting continuity now. So I'm going to hook or put this back in the circuit and use this side of the control rather than the other side, and I think it'll work out alright. Alright, that did the trick. Now I got the calibration dead on center, and we have 6.3 volts at the tube socket. I'm going to put this back together now, and let's try to actually test the tube. Okay, since it's already set up for a 6v6, let's try testing some 6v6s first. So, plug it in, turn it on, and double check my settings. A should be 4, B should be 6.3, C should be on 13, up 5, wrong, wrong thing, sorry. C should be 42, up should be 3 and 4, and down should be 2, alrighty. Now notice when I stick the tube in, that needle dropped a bit. That's typical, because the tube is drawing current now, which is bringing down the voltage for the whole tester, so you need to tweak that line adjust to get it back dead on that line. That's very important. Let's check for value. Alright, so it's in the good. It's not great, but it's about a third of the way into the green. Now what I'm going to do now is I'm going to put the same tube in my triplet tester and see how it tests in that. Here that same tube is in my triplet model 3413B, which I use all the time, and I'm confident it is working properly. I've let the tube warm up for a while, and if I check the value, It's very similar. It's about a third of the way up the good range. So I think so far this night tube tester is working properly. I'm going to grab a few more different tube types and give them a try. One type of tube I'm especially curious about testing is the new Vister. I've picked up a few of these over the years from TVs and here and there, but I've never actually owned a tester that could test these. This in particular in my hand is a Type 6D S4. I've come across these in TV tuners, but I've heard there were also some nifty little radios and tape recorders that use these exclusively. This is from, I think these came out in the 60s, so they were kind of competing head to head with transistors. But I guess these had certain characteristics that were superior, so they were around for a while. 6.3, 38, or 39 rather. Okay, there we go. I finally figured out how to put it into the socket. I've never actually inserted one of those into a socket before. Base is kind of weird. What do you know? It's good. Alright, very cool. So sure, these are only basic emission type testers, but it can handle just about any type of tube you're likely to encounter. Compactrons, new Visters, and so on. In fact, I'm going to pull out some Compactrons now and test those. Okay, so here is a Compactron. Specifically, this is a new old stock Type 6GF7. What Compactrons are is sort of the last hurrah of the vacuum tube, where they put 2 or 3 functions inside of one tube. So if you look closer, you see that there are actually 2 different plates. So there's probably like a diode or triode and a pentode, something like that, inside of this one envelope. It was a way to reduce the tube count. So say a TV would normally have 20 tubes, maybe it would only have 10 or fewer if you used all Compactrons. These were used mainly in the 60s into the 70s, and then finally transistors completely took over. So I already located the 6GF7 on the tube chart, and I have all the levers set up and whatnot. So I'm going to pop this in. So none of my existing tube testers have Compactron sockets. This is not my tube tester, but while I've got it here, I might as well test a few tubes. But actually, really the main reason I don't have one that can test Compactrons is I don't actually have any sets that use Compactrons, so I've never really had a need to test them. But it's kind of nice to be able to, just to see if the tubes I've been stashing away are actually any good or not. Alright, you can see it's glowing. Now, something I didn't mention earlier is that, I don't think I mentioned, is the shorts test. There's a neon light over here. And you should really test for shorts before you check for the value of the tube. To do that, you flip these levers up. But you only flip the ones up that are not in parentheses in the first column and are not already up or down. Okay, for something a little different, I pulled out an Arcturus tube, a Type 51 with the cool blue glass. And I know this one tests really weak in my other tube tester. Also notice that they don't actually list this type tube in this scroll chart. I think they only put the more common tubes in the chart, and for less common older tubes you have to pull out the actual manual. So here we've got a 35, A should be at 4, voltage 2.5, 56. I finished the setup for this Type 51 tube, including putting on the grid cap lead, and I've let it warm up for a while. I already checked for shorts, so let's check the value. Excellent. It tests well into the bad, just like it does on my other tube testers. So I am calling this tube tester fully functional and calibrated. I hope you all enjoyed this video on restoring a Knight KG600B tube tester. I guess you could call this the first of my Friday night, one-night restoration projects. So far I'm 1 for 1. We'll see how long I can keep that up.